welcome. I'm going to record a big video for mechanics playlist. And next thing is kinematics of a particle, kinematics or kinematics of a particle. Perhaps I need to explain two terms here. First one is kinematics. Kinematics का क्या मतलब होता है? Kinematics is basically when we discuss motion of a body, motion of a particle. Particle is an idealized model of a body. But when we discuss kinematics, we don't discuss the causes of motion. Well, we are discussing technically the motion, but we don't discuss the causes of motion. Motion is caused by forces. We all know about it. So basically, technically, we are not going to discuss the reason behind the motion. That means who is creating this motion, who is responsible for the motion, what are the factors that are maintaining the motion, or that and those factors who are destroying the motion. We just simply don't discuss them. We simply discuss the geometry of motion. That is called some particle is moving from somewhere to another place. यहाँ से वहाँ जा रहा है और कितनी तेज़ी से जा रहा है, हाउ फास्ट, कितना डिस्टेंस ट्रेवल कर रहा है, क्या डिस्प्लेसमेंट हो रहा है, इस किस्म के टर्म्स. तो किनेमेटिक्स में तो ये डिस्कस करते हैं. दूसरी चीज़ होती है पार्टिकल. पार्टिकल क्या है? तो बेसिकली व्हाट इज कॉल्ड ए पार्टिकल इज अ सिंपल क्वेश्चन. वी ऑल लिव in a world where particles exist, but we can't see them with our naked eyes. Of course, we can't see them. But describing motion of a body at once is a critical task, very difficult one. So we simply idealize them. That means they have no internal structure. We neglect few things about the bodies, like they are not rotating or like this. They have no internal structure. We simply consider a point in the body and describe its motion. That is why we treat them as a particle. This is a very simple explanation though, but we will know in future what these descriptions exactly mean. Right now, this is not part of our discussion. So particle is some idealized model of a body having no structure. And then we are going to discuss a rectilinear motion of a particle. Of course, rectilinear motion means a straight line motion. So our particle is moving along a straight line, and we are going to discuss the various aspects of its motion. तो कैसे करेंगे ये डिस्कशन? तो ऐसे करेंगे. लेट एक एग्जांपल लेते हैं. सपोज दैट दिस इज आवर एक्स एक्सिस, दिस इज आवर ओरिजिन, और ये पार्टिकल एक्स एक्सिस के लॉन्ग स्ट्रेट लाइन के लॉन्ग मूव कर रहा. तो जाहिर सी बात है इसका एक्स कोऑर्डिनेट वैरी कर रहा है. इट्स एक्स कोऑर्डिनेट इज चेंजिंग विथ रिस्पेक्ट टू टाइम. तो एक्चुअली माई लेग इज हर्टिंग. The problem of muscle stretch, so I can't be static right now. So still I'm preparing this video, standing on my feet and trying to describe few things. So if you find it awkward, please forgive me. So this is our origin of x-axis, and a particle is moving at any moment of time. Its x coordinate will simply describe its position. That means position of a particle, and that is the x coordinate, and the observer is sitting here at the origin, and suppose its x coordinate is varying with time, like this equation. So that this equation tells us that at t equals 0, its x coordinate is also equal to 0, and if you can closely describe the dependence of x coordinate on time, you will see this is tactically chosen equation, x in terms of time. And if you put t equals 6, you will get x equals 0 as well. So I can get one thing: if I put t equals 6, x will be equal to 0. That means particle is going to move somewhere from origin to somewhere at and then it returns back to x equals 0 at t equals 6 seconds. 6 सेकंड पर ये वापस आ जाएगा. And what next? So the first thing I would like you to do to describe in detail how the x coordinate of the particle is changing. तो डिस्क्रिप्शन कैसे दें? तो डिस्क्रिप्शन देने का एक तरीका होता है, you use mathematics. Mathematics means try to draw the graph of x versus t. Like graphing. Well, graphing is an art basically. Mathematics is also an art. और ये आर्ट पूरा का पूरा ये ऑब्जेक्ट t equals 0 से t equals 6 सेकेंड के बीच में क्या क्या करेगा, how its x coordinate will change, you will be able to describe it moment after moment. So that is called picture in picture description. That means t equals 0 से t equals 6 सेकेंड के बीच में क्या क्या हुआ, you need to describe each and every moment of its motion. So you need basically to draw the x versus t graph. And how can you do this? You have two informations here. At t equals 0, x is equal to 0, and you have to draw x versus t. That means you know few things. At t equals 0, the object was here at the origin, and at t equals 6 seconds, the object was also at x equals 0. That means here. Now describe what happens in between. So I'm going to do one thing, as the mathematics suggest, the calculus suggests, that I'm going to differentiate this thing. Like I have the equation x equals 6t square minus t cube, and I'm going to differentiate it dx upon dt. Find the derivative of x versus x with respect to t, and you are going to get something like 12t minus 3t square. And if you wish, you can take 3t common from the equation, and you can write here 4 minus t, 3t, 4 minus t. That means you will be able to see from here, ये पता चल सकता है कि dx by dt का वैल्यू जो 0 होगा, that will be at two values for t. When t is equal to 0, it's dx by dt is equal to 0, and when t equals 4 seconds, dx by dt is also 0. And if you put t equals 4 seconds here, you will get the value of x equals 32. T equals 0, x is also equal to 0 from this equation. But if you put here t equals 4 seconds, you will get x equals 32 seconds as well. and then dx by dt is 0 at 2 points, first at the origin and second at 4 t equals 4 second, and when x is equal to 32 meter. If I take x in terms of meters, this is another point called 432. So we need, I've just put here t equals 2 second, 4 second and 6 second, and I can do one thing: 8 second, 16 second, 16 meter, 8 meter x. This is for x in meters, and this scale is for t in seconds. This axis I need to say. So dx by dt is equal to 0. That means you perhaps know that dx by dt derivative is 0 here. That means you are going to get a tangent here at t equals 0, and at x equals 4, t equals 4 and x equals 32, you are going to tangent like this. And if you want to do something, you can do many more things, like if you can differentiate dx by dt once again if you want to, though the graph of the x versus t is already clear, but if you want to, you can differentiate it once again, find d2x upon dt square, and that is going to give you 12 minus 60. This 12t differentiation is 12 and 3t square derivative becomes 60, and if you can find for what value of t d2x by dt square is equal to 0, and I guess you are going to get t equals 2 second from here. 12 minus 60 equal to 0, you will get t equals 2 second. And if you try to find at t equals 2 second what will be the value of x, you can get it from here, and I think x will become 16 meter here. And you can see one more thing: at t equals 2 second, d2x upon dt square is equal to 0. But what if t is less than 2 second? If t is less than 2 second, d2x by dt square is positive, and for what if t is more than 2 second? T is greater than 2 second. This thing will become greater than 12, so that means d2x upon dt square will become 0. And this has a specific meaning. Between t equals 0 to 2 second, the graph will have the shape like this, like concave upward, and for t is greater than 2 second, d2x by dt square second derivative is negative, so that means t equals 2 to 6 second, because 6 second when t is greater than 2 second. Since we are discussing our motion till t equals 6 second, we can go beyond, but we are restricting ourselves to 6 second because nothing is going to happen afterwards. Between t equals 2 second to t equals 6 second, your graph will be like this, concave downward. That is the property of second derivative. So I think considering all these things, you are going to draw your graph like this. T is, here is the tangent like this, so graph will start like this, go to t equals 2 second, t equals 2 second, graph will be like this, like this, and then from 4 to 6 second the graph will be like this with the tangent at t equals 4 second. Graph will be like this, and t equals 2 second. The curve changes its concavity. It becomes it becomes concave downwards, and before it was concave upwards. Between this time interval 0 to 2 second it was concave upward, and between 2 to 6 second it was concave downwards. The graph will be like this. Of course, I made this graph in a pathetic manner. Technology is not perfect, but it's not bad either. Okay, it seems okay to me. The graph will be like this. So what happens? You can simply say that from the object starts from x equals 0 at t equals 0, टाइम t equals 0 पर ऑब्जेक्ट x equals 0 पर था, and then x coordinate increases, and t equals 0 पर origin पर था, and t equals 4 second पर ये 32 पर पहुंचा x का वैल्यू. दिस इज x axis, and then x starts decreasing. This is of course t equals 0 second, this is t equals 4 second, and it again reached at x equals 0 at t equals 6 second. So ऑब्जेक्ट की जर्नी कुछ ऐसे हुई है, ये आगे गया है यहाँ से, फिर यहाँ आ गया. It will be like this. So you now know x coordinate changes, but you can see one more thing. The displacement in 6 seconds, that means in time interval 0 to 6 seconds, the displacement of the object. And what is the displacement of an object? I'm going to define it. The displacement in rectilinear motion, displacement is nothing but change in position. So the displacement of a particle in rectilinear motion, when the motion takes place along a straight line, the displacement is simply defined as change in position. And position here is defined by the x coordinate. That means change in position is simply delta x, that is final value of x minus initial value of x. x2, let's call them x2 and x1. So it will become x2 minus x1. This is the change in position. Though one more terms comes with it, and that is called the distance travelled, not distance. I expect you to call it distance travelled all the time, in place of simply calling it distance. Distance, if you are calling distance, that means that represents the distance between 2 points, and it's always a straight line. This is a mathematical term used in coordinate geometry. The distance traveled is a real term used in physics. So distance traveled is what? This is the path length, रास्ते की लंबाई, path length. The total length, path length covered by a particle in a given time interval. That is the distance traveled. And if you look at this graph, you will say the displacement in the time interval from t equals 0 to t equals 6 seconds, 0 से 6 सेकंड के बीच में the displacement is 0 because the final position at t equals 6 seconds x is 0 and at t equals 0 second its position was also x equals 0. So delta x simply becomes here 0 minus 0, that is 0. So displacement is 0 in the time interval t equals 0 to t equals 6 seconds. But the total distance travelled is not 0. You know, this path length is 32 and this path length is again 32. That means the total distance travelled is 32 multiplied by 2, that is 64 meter. So that means one more thing I guess here. Displacement can increase and decrease within a time interval. But distance travelled is the length of the path. That means it always increases no matter in which direction you are moving. The displacement always increases. The distance travelled always increases. So when you try to draw a distance time graph, if needed, you have to make it sure that the graph goes upward, it's also always increasing. So the displacement time graph may be increasing, decreasing, but distance time graph always increases. So if you, and one more thing, this x here is position and displacement both, because the object starts its motion from the origin. If it has started from somewhere else, suppose from x equals 1, then its displacement and position have different values in a given time interval. But in this case, displacement and position are same thing, so you may call it x, you may call x position or displacement. Both are same in this case. So if you ever try to draw a distance time graph out of a displacement time graph, then focus at the points where the displacement goes on decreasing. When the curve falls, try to consider this tangent here. And if you want to convert this displacement time graph to a distance travelled versus time graph, path length versus time graph, just draw a mirror image of this graph so that it seems increasing all the time. This graph is distance travelled versus time graph, and this is displacement time graph. Apart from these things, you have noticed in this graph that the particle starts from origin, goes to x equals 32 at t equals 6 seconds, and then come back again covering the same path. Oh sorry, t equals 4 seconds, t equals 4 seconds, goes to x equals 32 at t equals 4 seconds, and come back to x equals 0. It was at t equals 0, and come back again here when t equals 6 seconds. So if you divide this journey into two parts, one in the time interval from 0 to 4 seconds, another from 4 seconds to 6 seconds, it travels from x equals 0 to x equals 32 first in 4 seconds, and then travels x equals 32 to x equals 0 in just 2 seconds in the time interval t equals 4 seconds to 6 seconds. That means it traveled the next 32 meter in just 2 seconds and first 32 meter in 4 seconds. That means it was moving at higher speed in the later part of the motion, and it was slower in the first part of its motion. So sometimes you will need to find out what is the rate of change of displacement or the distance traveled. So move to the next section and talk about rate measurers. And our derivative is a rate measurer. We know famous rate measurer. Derivative's other name is rate measurer. But we will find here another kind of rate measurer, that is called average rate measurer. Average rate measurer. And if you consider the whole time interval, that means between t equals 0 to t equals 6 seconds, then if you consider between t equals 0 to t equals 6 seconds, the average rate measurer of displacement rate measurer of displacement, and basically rate measurer of displacement is called average velocity. Rate measurer of displacement is called average velocity. That is the time rate of change of displacement. And rate measurer of displacement in a finite time interval is called average velocity, or you can simply like it delta x upon delta t. And so between t equals 0 to 6 seconds, the average velocity is 0. But if you consider t equals 0 second to t equals 4 seconds, and another interval from t equals 4 seconds to t equals 6 seconds, you can see between 0 to 4 seconds, the delta x was 32. Delta x was x2 minus x1 divided by delta t was t2 minus t1, and x2 was simply 32, and x1 was 0, and t2 minus t1 is 4 minus 0, and you will get 8 meter per second. So between 0 to 4 seconds, the average velocity is not 0 but 8 meter per second, and between t equals 4 second to 6 second, delta x upon delta t becomes x2 minus x1 upon t2 minus t1, and that is 0 minus 32 divided by 6 minus 4, that is minus 32 by 2, that is minus 16 meter per second. Here minus sign simply represent that displacement is now decreasing. The object is retracing its path, but at a faster rate, 16 meter per second. It is faster this time. And for average speed is another rate measurer, and that is the rate measurer of distance traveled, path length, rate measurer of path length. Path length. And of course it can be explained like distance traveled by time taken in a time interval. If you want to calculate it between 0 to 4 seconds, the distance traveled is 32 meters and time taken in 4 seconds, so it will become 8 meter per second. And again between t equals 4 second to 6 second, the distance traveled is again 32 meter, the path length is 32 meter, but the time interval is simply 2 seconds, so it will be 16 meter per second. That means in the second half of the motion, the particle is faster, and of course average when between 0 to 6 seconds, the displacement is 0, that means average velocity is 0, but average speed is not, because average speed is the rate measured of distance traveled, and those total distance traveled between t equals 0 to 6 seconds is 64 meter and time taken is 6 seconds. So you can find 64 upon 6, and that will give you the average speed, value of average speed. So you know few things from this video, that x versus t equation gives you how the x coordinate of a particle changes with respect to time. What is our displacement, what is the distance traveled, what is the average velocity, what is an average speed, and I think describe many notifications and providing you many formulas. You need to know the terms itself, and I think this is a way of thinking. Thank you very much for watching.